What is a string inverter? What is a microinverter? If these terms are already familiar to you, you're probably in mid-journey looking into solar. We take a lot of pride in this aspect of the effort because there is no one-size-fits-all solution. There are a few variables that factor in to the benefits of one application or another, and they need to be designed and engineered for your specific solution, your specific set of variables, and we take a lot of pride in that. So what is a string inverter? Well, string inverter, as the name implies, is when the panels are strung together, they're wired together, and then they're connected to the inverter in question, which is going to do the heavy lifting of converting the energy from DC to AC. The first grid-tied inverters, which were really a very significant technological advancement in our industry, were all string inverters. So there are projects where a string inverter is going to perform very well and in many cases be slightly more cost effective. So it's an appropriate solution for projects like that. So as with most technologies, there are both advantages and disadvantages. One of the disadvantages of a string inverter is that all of the panels that it's serving in that conversion from DC to AC are vulnerable if it fails. So it's not unfair to say that that's a large single point of failure. However, a lot of the string inverter manufacturers have also incorporated what is referred to as panel level support. So there is something out at each panel that's providing insights onto how the panel is performing and even sometimes optimizing its energy production. Now, microinverters. What is a microinverter? As the name implies, the inverter is very small, and it's been designed and engineered to accommodate the power production of a single panel. So with microinverters, you really have a one-for-one relationship with the inverter and the panel. That eliminates the single point of failure that you saw in the string inverter, so that's its core advantage. It also allowed for panel level monitoring. So from the inception of microinverters, they have had those benefits of very modular level insights into how the system is performing and then eliminate single points of failure. So imagine if you have a single panel out, you're going to be able to see that and address that. All of the other panels, meanwhile, are functioning fine. Okay, so what are the disadvantages? Well, microinverters have a different level of cost, particularly at scale. They are very, very favored in certain applications, particularly on residential rooftop jobs, where the panels might be on several different levels, they might have several different pitches or even orientations to the sun, all of which will affect performance, and therefore you want the microinverter so that the panels are performing independently of the other groups of panels on the roof. In fact, kind of a bedrock of that technology was thinking through how residential roofs are engineered and built, and then engineering a solution that was best for them.